Welcome, welcome, welcome. We have some magnificent speakers, so please take your seats so we can get started. Let's get the party started. I'm Teresa Crimmins, the Assistant Director for the USA National Phenology Network, and it's my privilege and pleasure to welcome you here today to the campus of the University of Arizona. We acknowledge that the University of Arizona campus is situated on the traditional and ancestral territory of the Tohono O'odham people. We have come together to celebrate a major milestone today. The USA National Phenology Network has been in existence for 10 years. Today, we appreciate and celebrate the efforts of so many individuals and institutions that have played a role in envisioning, establishing, sustaining, and growing the network. We have visitors here from as far as Maine, Florida, Minnesota, and California. And that you are all here today demonstrates your strong commitment to this endeavor. The USA Phenology Network encompasses thousands of volunteer observers and many, many partners, including research scientists, resource managers, educators, and policymakers, supported by a national coordinating office. The network also extends to creators and users of USA-NPN data products and resources. We are very grateful to the many, many people, tens of thousands in fact, as well as countless organizations, partner groups, and agencies that have played a role in establishing, shaping, and sustaining the USA-NPN and its programs and resources. I want to take a moment to formally thank these organizations and individuals. I'm certain that despite our best efforts, we'll end up inadvertently leaving a lot of people out, and I sincerely apologize for that. Please see the back of your program, hopefully you got one of those lovely programs, for a more comprehensive list of the many, many individuals that have contributed to the USA-NPN. And if you notice any omissions, please let me know after the program has concluded, as we'll be maintaining a list on our website. First, we owe a debt of gratitude to the members of our former board of directors and advisory committee, with particular appreciation to board leaders Mark Schwartz and Julio Betancourt and Jeff Hennebree. These individuals played very important roles in formalizing and shaping the USA-NPN, and also in securing funding early on in the network's existence. Next, we are very thankful for the efforts of many within the U.S. Geological Survey, including individuals that were instrumental in providing funding for the network. We thank the USGS for providing major funding since the inception of the USA-NPN in 2007. There are many individuals at the University of Arizona that have made major contributions to the establishment and growth of the network. In particular, former Dean Eugene Sander, Chuck Hutchinson, Dave Brashears, Baron Orr, Andrew Comrie, and Stuart Marsh all played important roles in securing the University of Arizona as the host institution for the network. We are also very grateful to our former staff members, students, and collaborators at the university. We thank the U of A for serving as our host institution since the USA-NPN's inception. We also thank the several institutions that have provided monetary support for the network, including the U.S. Geological Survey, the National Science Foundation, the U.S. Fish and Wildlife Service, the National Park Service, the Wildlife Society, NASA, NOAA, the University of Wisconsin-Milwaukee, Oak Ridge National Laboratory, and the EPA. We are indebted to the hundreds of partnering organizations that have worked with USA-NPN in various capacities over the years. This is just a small sample of the organizations working with the USA-NPN to collect phenology observations, engage members of the public, advance our understanding to the patterns and drivers of phenology, and make informed natural resource management decisions. Finally, we are extremely thankful to the many, many people across the country and even beyond the US borders that have adopted our observation protocols and Nature's Notebook to undertake long-term phenology monitoring at their locations. We thank the hundreds of local phenology leaders that engage in many individual observers in using Nature's Notebook at their venues, the hundreds of local phenology program members, and of course, the tens of thousands of individuals that participate in Nature's Notebook and contribute daily to an irreplaceable and unprecedented observational data set. And now I'm very happy to turn it over to our wonderful series of speakers. We have a fantastic roster of speakers representing USGS, the University of Arizona, and several of our partnering institutions. We are live webcasting this event and also recording it so that others that aren't able to join us here in Tucson today can still be a part of the fun. Unfortunately, we won't have time for questions after the speakers' presentations because we want to stay on schedule so you can enjoy the hors d'oeuvres that will be waiting for us outside soon. Our first speaker today will be Jake Weltzine, delivering words on the behalf of Ann Kinzinger, Associate Director of the USGS Ecosystems Mission Area. Ann unfortunately had to cancel her travel on very short notice, so Jake has agreed to deliver her comments on her behalf. Jake is an ecologist with the USGS and also the USA-NPN Executive Director. I should mention really quick too, for you and for all the speakers, you got to stay put because this is the microphone, and if you walk away from it, then our wonderful people who are joining in from afar can't hear. He doesn't have slides.
Well, thank you, Teresa. That was wonderful. I'm really sorry that Ann Kinzinger couldn't be here. She had travel complications and couldn't make it, and so she asked me if I would go ahead and cover with her talking points. And I said that was sad that we wouldn't be able to have you here, but I can do the talking points because I wrote them. I wasn't going to have a chance to have a slot, and now I'm very, very pleased to be here. So you've heard a lot about U.S. Geological Survey here. I'm going to try to stay true to Ann. You've heard a lot about U.S. Geological Survey, and really, you know, it's the power, it's the money, if you will, it's the vision behind the initial idea to make this thing work. So I'd like to just describe for you just a moment about the Ecosystems Mission Area, which does provide those resources and where I work within USGS. It's the research arm for the Department of the Interior. The Ecosystems Mission Area was formerly what you might have known as the Biological Resources Discipline, and before that it was the National Biological Survey, and before that it was even the National Biological Service, or got that mixed around. But in 1996, it was brought into USGS. So the Ecosystems Mission Area now, it's around $160 million a year, focuses on invasive species and disease, wildlife and fisheries research for pre-listing conservation, things before things get imperiled, and after, and we're trying to recover them, coastal sustainability, ecological flows, energy development, and building our future workforce with the cooperative research units, as well as continental scale monitoring, creating legacy data sets like the Breeding Bird Survey, or managing the bird banding laboratory, or emerging activities such as the North American Bat Monitoring Program, and for the last 10 years, the USA National Phenology Network. So just a quick history on the NPN. The NPN was sort of seen as a unique opportunity. It's really not often you get to develop a new national science and monitoring network. And so the vision behind it was to create a sentinel network, if you will, for plants and animals and their response to climate change and the mechanisms that are driving that, and then those responses that we might see across the landscape. The mission was to collect, manage, and share phenological data and data products to advance science and inform decisions. And I'm going to come back to that in a few minutes because that's part of the strategic plan. It was originally seen as a complement to the National Ecological Observatory Network, which was in development back in those days, 2004, 2005. NEON would have about 60 sites, but the NPN was envisioned to have tens of thousands of sites, which we actually have reached. And the data are now complementary between NEON and the National Phenology Network. They use our protocols, we have APIs, we share data. So Julio Betancourt and Mark Schwartz, of course, who are here today, co-founders of the network, are instrumental and were part of why we're here at the University of Arizona. Julio convinced USGS leadership of the great idea that the Phenology Network was and to provide some initial funding. And Mark shared his vision and his long-term data sets that became the backbone of the network. A collaboration with the University of Arizona was seen as optimal, like a startup. Something brand new like a continental scale monitoring program would need a nimble development. Also, we probably needed to put it away from USGS headquarters in Reston, Virginia, so that it could be open and apparent for everybody to be a part of, as envisioned as an organization that would be open to all. And seed money was created to create that relationship with the University of Arizona. So the NPN opened its doors in 2007 with 2 staff. Mark Losslaben from the University of Arizona was part of the cooperative agreement at halftime, and myself. So Mark and I sat down. Oh, I'm going off my talking points, Anne's talking points. I'll tell that story later. So about 1.5 FTEs. Over the last 5 years or so, the NPN has been stable at about $1 million a year with about 8 FTEs. So we're very happy about that. So the total investment has been about $12 million. So USGS made a major commitment to the activity. However, there's been other monetary and in-kind support, not to mention the involvement of the University of Arizona, but the National Science Foundation provided $500,000 to create a research coordination network. Very helpful as we got up and got rolling. NASA, NOAA, and EPA, and many of the bureaus in the Department of the Interior, BLM, Park Service, and Fish and Wildlife Service, especially Fish and Wildlife Service, which is helping fund the operations of the activity. So that's perfect collaboration working together. So the NPN is actually still required to meet federal policy because USGS provides resources to the University of Arizona in a cooperative agreement. And so they stipulate that it has to follow federal policy, including the Paperwork Reduction Act, the Privacy Act, FSMA, data quality, et cetera. And so I could go on quite a bit. What I'd like to point out is that that was quite a burden on the University of Arizona staff to have to comply with federal policy. So I thank you. And we are actually leading the development of policy compliant products and information out of USGS. For example, we're the first mobile app in USGS to meet the new security measurements, and actually was the first mobile app produced and approved for information collection in the Department of the Interior several years ago. So University of Arizona is creating amazing products. So I'd like to turn now to the strategic approach being adopted by the Phenology Network. There are 3 parts to the strategic plan: advancing science, informing decisions, and communicating and connecting. And communicate and connect really applies to both advancing science and informing decisions. I'd like to just spend a moment kind of talking about that as a frame for, have we advanced science? Have we informed decisions? So Nature's Notebook, which is the ground-based observation system within the National Phenology Network, probably many of you are very familiar with that interface, went live in 2009. It's where you go get standardized monitoring protocols for over 1,300 plant and animal species across the nation. And it was designed for both professionals and volunteers. So that has been an amazing product. I'll talk about the awards a little bit later on. It also produced an amazing data set. We have over 15 million records contributed by 13,000 observers at 26,000 sites on 54,000 unique organisms, plants and animals, hundreds of species. There's a lot of information there, a lot of data. It's all freely and readily available. And there's been about 60 peer-reviewed publications that have come off of the data or the models curated now by the Phenology Network, are being developed by the Phenology Network since 2009. In such journals like Global Change Biology, Nature Communications, Science Magazine, and Ecosystems. So truly advancing science. The second plank is informing decisions for natural resource managers. The goal is to try to work carefully with resource managers to understand what is it that they need and how can we best meet those needs. And what I'd like to do is kind of give you two quick examples of how the collaborations have really worked very, very well. I'm going to focus on Park Service and Fish and Wildlife Service, 2 of the DOI bureaus. The first is understanding changes in seasonality, trying to understand how is seasonality, or say indicators of spring or timing of seasonal activities changing both within and across our national parks and our fish and wildlife refuges, our national wildlife refuge system. Hundreds of parks, hundreds of national wildlife refuges. So the team of the Phenology Network worked together to leverage on the spring index models that were developed by Mark Schwartz. We'll hear a bit more about those as we go along, and produced a couple of papers co-written with Park Service and Fish and Wildlife Service staff, published in PLOS One and Ecosphere, that examined the onset of spring across those protected areas and actually the continent over compared to last century. What they found is that 3/4 of all these protected areas now have an earlier spring relative to this last century. And fully half of those protected areas have now what we call an extremely early spring. So conditions are changing radically across our protected areas. We also saw changes in shifts in the timing of habitat availability along the migratory flyways for North American migratory birds. We also saw changes in seasonal breeding habitat conditions as well. And so the challenge, I think, is going to be delivering that information back into the hands of the parks and the refuges to work carefully with them to help them understand, okay, how do we now apply this information to improve resource management decision making? Second example I'd like to give is something actually very topical, of high priority to USGS, and we're very happy to have these activities supporting one of those priority areas, and that is invasive species detection and control. So we're very interested right now in improving early detection, rapid response, and building a biosurveillance network for both invasive species, but also disease. We'll talk more about that a little bit later within national parks and refuges. So at Midway Atoll National Wildlife Refuge, the staff there use Nature's Notebook to track the phenology of invasive species, Verbicina in particular, to help schedule eradication of the remaining patches there on the atoll. As a second example, right here in our own backyard at Saguaro National Park, staff and volunteers are working together to track phenology of the invasive bufflegrass, try to understand how that relates to precipitation inputs, and try to measure also and integrate it with satellite-based imagery to understand when do you actually go out and kill it. Get it when it's green. You can apply herbicide to remove the invasive bufflegrass, which can otherwise produce a huge fire problem, and we can lose our saguaros. In addition, the NPN creates products and tools requested by partners. We're very responsive, service first. Phenology calendars, species-specific protocols, custom mobile applications, custom viz tools, species-specific forecasts, such as for emerald ash borer or hemlock woolly adelgid, and notification services for early detection and rapid response. So I'd like to change gears now to that third plank, that communicate and connect part, because we could do great stuff as an organization, but if we're not getting the word out or engaging folks, where are we? So a key realization was that we would need to serve as a platform, if you will, for others to answer their own research questions, while also contributing to the broader effort. So that's really shaped what we do. Do this. We build tools and templates that now support over 450 active organizations that are partnering and contributing, actively partnering and contributing data through Nature's Notebook, again, to meet their own needs. Includes resource managers, academics, universities and schools, NGOs, cities and municipalities. Other organizations are now leveraging on this capacity as well to meet their needs. So for example, there was a full episode of Sci Girls called Flower Power a few years ago, focused fully on phenology. It was so great to see those kids waiting for the phenological events to occur on camera. It was fantastic. We had great collaborations with the Girl Scouts, Master Naturalists, and we'd like to announce for next spring a new PBS Nature Live documentary called Spring Live, featuring citizen scientists tracking the onset of spring live across the nation and using Nature's Notebook, as well as several other citizen science projects. It'll be in April, the last day of May, time live. We'll see how that goes. I'd like to just kind of feature a little story about these national maps of the onset of spring that were released operationally by the office in February 2017. We're in the spring coming. Well, look at the Phenology Network maps. Hundreds of media stories, an infamous Washington Post piece that read, USGS hails an early spring and blames it on climate change. So the communications office was very excited about the fact that they finally got the words USGS into the headlines of a Washington Post piece on the front page. Unfortunately, the timing was not so great with the new administration. So meanwhile, the indicator was adopted by the US Global Change Research Program, the EPA, as climate indicators, and is featured in the forthcoming 4th National Climate Assessment. So this success has been recognized by a number of prestigious awards and awarding organizations. The Phenology Network and Nature's Notebook received a Shoemaker Communications Award, a USGS Environmental Achievement Award, and a DOI Honorable Mention for Environmental Achievement, a Renewable Natural Resources Foundation Outstanding Achievement Award, the Association of Fish and Wildlife Agencies Climate Adaptation Leadership Award, and the National Association of Government Communicators Blue Pencil Gold Screen Award. So I guess they still use blue pencils. So where do we go over the next decade? It's been a fantastic 10 years, obviously. Jeff Morris said is going to provide a little aspirational or inspirational talk about that in a few minutes. So I'm not going to take away a whole lot of your talk, Jeff. We look forward to that. But from a more operational perspective, the Phenology Network is planning to shift is a little bit of strategy to sort of prioritize the informed decisions part. That's in part because of the pressures that we're getting from the administration, but also that's really the way that we can be very, very helpful to society, to resource managers. And so we're exploring and we hope to demonstrate the value of co-production to link scientists with resource managers in its variety of forms. The Phenology Network also hopes to help USGS develop capacity in ecological forecasting, invasive species and disease and species and management concern. When are they active? Where are they and when are they active? And help ecosystem scientists, as well as all scientists within USGS, learn how to deliver data real time. So not just floods, not just earthquakes, but also ecosystems. And then finally, to continue to explore the potential for citizen science as a tool for science and engagement. And with that, I will take off my Ann hat and just say, with my Jake hat on, that I am so honored to be here today. Never thought it would happen in some ways, could only hope. So we started out saying 30 years, we got 30 years, and so each year we go by, we got, okay, 28 years to be successful. Now we have 20 more years. So the challenge and the opportunity, of course, is where do we go from here? What do we do with these next 10 years? It's been fantastic. And I am so pleased to have all of you and to have everybody who we worked with so hard, all 13,000 observers and the staff and the former members of the board, and all written there on the back of your agenda. So check that out, and thank you so much for coming. I appreciate it.
Thank you, Jake and Ann. Next, we are very fortunate to hear from Dr. Shane Burgess, Vice President for Agriculture, Life, and Veterinary Sciences and Cooperative Extension, and the Charles Sander Dean of the College of Agriculture and Life Sciences at the University of Arizona. Dr. Burgess will speak from the perspective of the host institution of the USA-NPN, the University of Arizona. As Dr. Burgess will share with us, timing is everything. Oh, that's where I'm technical. Yes, it is. It is.
Well, good afternoon, everyone. What a pleasure it is to be here today to, whoa, this moves. That's very high tech, Stuart. I didn't realize that the thing moved. What a pleasure it is to join you today and really celebrate this 10-year anniversary and achievement. This first slide, it's got something unusual on it, and normally I don't put any qualifications behind my name, but I wanted to put two because I think they're really relevant to what we're talking about today, what I'm going to talk about today. Now, the first one is my MRCVS. That's member of the Royal College of Veterinary Surgeons. I'm a veterinarian, and I've worked in all sorts of areas all over the world, out in wild environments. I did fish farm work, for example, and understanding the timing of our natural environment is absolutely critical for animals who live in the wild environment. So as a veterinarian, I can guarantee every DVM in this country has absolutely no idea what and how the timing of the risk analysis for various parasites, various insects and things is done, but it's all done through this. And so it's very relevant to me. The second one, I don't know, someone may recognize that. That's my fellowship with the Linnaean Society in the UK. And so anyone who knows what the Linnaean Society is about, it's all about evolutionary biology. And of course, evolution is nothing more or less than a response to the environment the organism is in. And so I'm going to talk a little bit more about that today. So Teresa said it was her pleasure to introduce me. Not that many people say that, so thank you very much. I really appreciate you saying that. Certainly not my wife usually when we're going somewhere, but thank you. I really appreciate that. You know, I really was excited to see the not just my email inviting me, but to see the little information. Please join us. The little pretty information, pretty thing. I was in UAE this time. I was on the airplane coming back from UAE actually this time last week, and I had the pleasure of going to a particular event where people were recognizing Sheikh Zayed, who was it was his 100th birthday. He's dead now, but it was his 100th birthday for starting their country. And there was a quote, and that was, "Whoever has no past has neither present nor future." And so I think what the previous speaker said is very, very apt and very important. You know, people talk about standing on the shoulders of giants. But the whole point of this is that it's all about citizen science. And citizen science has come around and round and round again in my conversations over the last 3 months. And so we're not just standing on the shoulders of giants, but we're not just standing on the shoulders of the renowned, but we're also standing on the shoulders of everyday unsung heroes who've been doing citizen science for millennia. And I'll talk about that, I think, now. So citizen science, you could argue that what makes a human beings humans isn't our opposable thumbs, isn't our big brain. It's probably both our curiosity and our ability to work together. And unless we're continuing to be curious, we can never be innovative. We can never take pre-existing things and change them into something different. And so if we look at human beings and their interactions and survival in the environment, right up to the point where we're having large, massive effects on the environment, it's all got to do with the fact that we've got these enormous brains and can communicate together. And the best thing about it is our brains are all different. So we all think in different ways. But these folks were citizen scientists right from the beginning. This little picture here is Mr. Euclid. I don't know if they used that terminology back then. But around 300 BC, this Greek mathematician wrote a text called Elements. And these are theories which are still used today in geometry. And of course, they came from natural laws in the natural world. Again, looking at the natural world and changing them into mathematics. Instead of mapping the natural world as is being done and celebrated today, it's understanding the natural world and mapping it mathematically. That was 7 centuries before the first university was established in Europe. And some of you may have taken a road in Tucson, which is called Euclid Avenue. And that road is named after Mr. Euclid. I won't tell you why and how. You can go find that out. It's pretty simple these days. Just Google it while you're sitting there not listening to me. But so what's really interesting to me, though, is while the NPN is located in this ivory tower, its strength comes from the majority of people who, like Euclid, were not faculty. So Euclid couldn't have been a faculty member because universities didn't exist. I'm not sure the Greeks would have agreed. If you understand the Greek philosophers, I'm not sure they would have agreed with universities anyway. Although they were busy arguing with each other, and that seems to suit well in universities today. But anyway, the middle person is someone who's a personal hero of mine. Does anybody know who that is? Anybody here consider themselves an evolutionary biologist? Surely someone in this room must. Stuart, I'll blame you. Stuart's yes, sir. Who is that? Close, kind of. He's a surveyor from England. That's Alfred Russel Wallace. Ring any bells? He's the guy that told Darwin how evolution should work. Okay, so he's officially the co-discoverer of natural selection. I'm a particular fan of Wallace's because, unlike Darwin, Wallace didn't come from a family of wealth. He wasn't blessed with a support system where he could lounge around and fail at one thing and fail at another and then go gallivanting around the world. Wallace had to work for a living. He was a surveyor, and he actually left school at 14, was apprenticed, became a surveyor, and while he was a surveyor, he got really interested in entomology because he met a guy called Henry Bates. Now, I have no idea who Henry Bates is, but I can guarantee you anyone who's an entomologist does. I saw someone nodding, so someone, who knows who Henry Bates is? Yeah, I saw you nodding way at the back. Great. Are they famous? They are. Good. Okay, good. So anyway, while he met Henry Bates, he got really excited about insects. And then he was supposed to be surveying a railway. And instead of surveying a railway, he kept drifting off collecting insects. And so he was a citizen scientist. But really, the whole theory of evolution by natural selection started with citizen science. And it's continuing today because really all of the phenology that we're seeing today is affecting evolution. I mean, evolution is a result of what we're seeing today. But what's really interesting to me is, and especially at this university, which is renowned as an astronomy university, a university in exploring space, in 1904, he wrote a book called Man's Place in the Universe. And this was the first serious scientific attempt by a biologist to evaluate the likelihood of life on other planets. And I think that's really interesting that the NPN is located here at this university, especially with the OSIRIS-REx mission, which is now going to take a piece of an asteroid to come back and replicate what was done in the mid-1850s and look at the origins of life from a universe level. And so I think this is really neat that these connections occur. He was also one of the very first prominent scientists to raise concerns over environmental impact of human activity. So he's a pretty amazing guy. And he wrote on both scientific and social issues. All of it done at a time where science was a hobby, where everyone was a citizen scientist, and most of those were incredibly wealthy, and he wasn't. There was a contemporary of Wallace's, and this lady on the right, her name was Sarah Ellen Plummer Lemon. And she visited Tucson in the 19th century, and she was a citizen scientist too. She was a botanist. And she decided one day she'd scale that mountain out there that you see overlooking us, and now we call that mountain Mount Lemon after her. So I think that's quite an interesting, if we look at history and how it brings back, and now we have Nature's Notebook, virtually located here at the University of Arizona, but located in the pockets and on the phones and on the computers of all of the citizens in the United States. All they need to do is want to do it, and they're welcome to do it. And I think that's really a remarkable thing. And I think citizen science, I think we're at the burgeoning of a new time of citizen science. And I think the NPN has been leading this. I think in the next, you ask what's going to happen in the next 20 years, we should see much, much more of this. And we're seeing more right through in biology and astronomy all around this university is being impacted by it. Here are some statistics. I really hate reading slides. It's not because where I grew up, I didn't learn to read. It's because, does anyone understand what I'm saying with my accent? Yeah. There's a whole bunch of people nodding seriously as if that wasn't a joke. You know, I lived in Mississippi one time, and people would say, "You're not from around here, are you?" And I'd say, "No, I'm from the deep south." And one guy actually looked at me and said, "So which part of Louisiana is that?" Anyway, with that little aside, I think you've seen, I think you've been able to see some of the direct outputs from the program. And of course, outputs are important. Outputs are what our research scientists thrive on, but it's really the outcome of citizen science which is much, much more impactful. And you talked about the perfect timing of the report with the change in the administration. Yeah, I guess as a federal agency, that's kind of nerve-wracking. But for the future of the United States, I'd say it was perfect timing. And you may not have got as much press if it hadn't been. And that's what we like. If we take a leaf out of President Trump's book, perhaps no press is bad press. So that's great timing. But a lot of outputs there, and that's really great to see. What's more important, though, is not only are we seeing citizen science around the nation, but we're also seeing synergies here at the university. And these are really, really important synergies. And you can see, of course, the most important college up there, the College of Agriculture and Life Sciences. The first college in the whole state. Before the state was a state, it was a territory when our college started. There wasn't any other university. But we're the College of Agriculture and Life Sciences. Well, that makes it the most important. We could have put that on the bottom, the foundation of everything else. But then we have a whole lot of other colleges that other people consider important and we work with. And you can see the College of Science, obviously. The College of Social and Behavioral Sciences, I think, probably a really, really important partner, because you think about change in our society today, it's not about STEM. It's not about facts. It's not about data. If it was, everyone would love GMOs and no one would not believe in climate change, right? It's because it's about law, it's about policy, it's about social interaction. That's what drives change. And that's why this program is going to be so important when it comes to outcomes and not outputs. We have federal partnerships, of course, which are very, very important to us, especially in the School of Natural Resources and the Environment, which is the lead school, which is the school in which the NPN exists. We have local partnerships, which of course are important. ASDM, if you don't know what that stands for, it's the Arizona, oh my gosh, it's the Arizona Sonoran Desert Museum. I can't believe I forgot that. I'm on the board of it. College of Education and College of Public Health. Of course, it's patently obvious how public health is greatly affected by how our climate and weather varies. And that ties back to that point that I made about my MCVS. So just a couple of little examples, which I'm absolutely not qualified to understand, but if we look at the pheno forecast, short-term forecast, which are guiding insect pest control activities, that's very, very important, not just and only because of understanding how we can maintain our crop productivity, But it also has to do with how we do or do not spray nasty insecticides into the environment. And of course, we're talking about crops here. There's a pretty picture of an insect. I don't recognize it, but I'm sure one of our 3 or 4 entomologists does. I'm sure it's important. But there are insects that affect animals, and humans are animals too. I get told off for saying that. So humans and other animals, I'll say it again, get affected by insects. And, you know, you can just think of the most recently in the news Zika virus. And of course, you know, if we want a bit of a lead time, the NPN is going to help us with that. You know, it's all very well. We can just replace people with computers. That's the whole point of AI, artificial intelligence. And a lot of people are worried about that. I would say we need to think about AI, artificial intelligence, and then think artificial intelligence is facilitating the next phase, which is IA, which is augmenting our intelligence. But what I told my students when we were working in computational biology, when I was running a high-performance computing facility, is for some reason millennials and Gen Z, or those millennials and Gen Z in the audience, think that if a computer does it, it must be right. There's a little thing called sanity checking. Does it make sense? Does what the computer's spitting out make sense? And this is what's amazing. Without this program, without citizen science, we couldn't sanity check the top right-hand image of the United States. It's sanity checked with human beings. And you can see the R-squared value on this is only 0.66. So it says our computers are not infallible today. And that's fine, because one day they'll get better. I don't think in my lifetime I'll see infallible computers. I don't think in my lifetime I'll see a time when computers completely replace what humans are good at. I hope they absolutely replace what humans are awful at, and they're doing that now too. Seeing things from space is not something we're good at as individual humans, but double checking to see if the data is right is absolutely critical. So the leverage on this, the leverage and the outcome leverage across this entire nation, and by the way, our neighbors to the north and south, is absolutely remarkable. And I do hope that message gets through to some of our leaders in the federal government and the federal agencies. So with that, I think I'm finished. With that, I'd like to finish, say congratulations, and I can't tell you how thrilled and excited I was when I came here 7 and a bit years ago to find out this institute was here. And unlike my friends in engineering and the College of Law, it's not about measuring bumps on skulls. They didn't know the difference. It's about measuring the future of our planet. So thank you so much, and citizen science.
Thank you. Thank you so much. I really appreciate it. Thank you, Dr. Burgess. Our next presentation will be by Dr. Susan Mazur, Professor in Ecology, Evolution, and Marine Biology at the University of California, Santa Barbara. And she will share some thoughts with us on how the USA-NPN has supported scientific advancements. Susan's presentation is entitled Beyond Phenophase Onsets, Using Observational Data to Link Climate to the Collective Properties of Communities and Flora. I'm tight up here.
Okay, thanks so much for the invitation to participate in today's festivities. It's so great to see so many of you who, oh, there's a little thing here, sorry, who I first met in 2005 at the NSF-funded workshop where the NPN got its start, simply as a brilliant idea promoted by Julio and Mark. Today, I've just enough time to share some thoughts regarding a few areas of research that I feel are wide open now that the NPN database holds such rich and well-curated phenological and climate data. So 13 years ago, we imagined how great it would be to design a national phenological network that would engage members of the public, students, and scientists with a goal of collecting enough high-quality data to measure the relationship between phenology and climate across large geographic scales. Using spatial variation in climate as a proxy for temporal variation, we felt pretty confident that observational data would enable predictions of the effects of oncoming climate change on a wide variety of phenological metrics. Now, 14 million observations later, we're poised to do much more than to predict whether and how individual species such as California poppy will alter their phenology in response to climate change. So for example, enough genera are now represented by multiple species that we can compare closely related taxa occupying contrasting climates to examine how phenological sensitivity has diverged between them due to both evolutionary change and plasticity. In addition, given that many locations in the US, observational data have been recorded for numerous species, we can now detect the effects of climatic conditions on community level phenological metrics. Third, with the availability of both high resolution climate data and observational data across broad climate gradients for many species, we can identify the climatic parameters that best explain variation in many phenological metrics, such as flowering onset, duration, et cetera. And we can take this, I'm going to argue today, much farther than just looking at the effects of the usual suspects like mean annual temperature, rainfall, et cetera. Now, to date, herbarium specimens, given their broad geographic and temporal span, going back a century or two, have begun to be used to achieve these goals, particularly the second and third. But herbarium-derived phenological data are potentially problematic because, for example, the date of specimen collection is an imperfect measure of, say, flowering time, because a specimen may have been collected at any time during its flowering period, not just at its onset. This means that the more precise NPN-derived data is an extremely important source resource for validating the models that are constructed using herbarium data, and I'll show you an example of this. So as an example of the first area of research comparing closely related taxa, in 2007, last year, Kathy Gerst from the NPN office, a grad student in my lab, Natalie Rossington, and myself used NPN data representing 2 West Coast oak species and 2 Midwestern to East Coast oaks to compare their phenological sensitivity to climate variation across their ranges. And our primary results were these. First, both groups of oaks respond as we expected to warmer and drier conditions by advancing vegetative bud break and or the onset of flowering. The California oaks, however, are much less sensitive to variation in temperature and rainfall across their range. And moreover, individual California oak trees have multiple episodes of bud break and flowering each year, while the trees of eastern oaks exhibit a single event. And we felt this would be the case just anecdotally, but we were able to demonstrate it. I'd hasten to say that whether these patterns apply to other genera is completely unknown, and we need to get to work on this to begin to clarify that possibility. Now, the phenological data, the records for most species observed by NPN participants represent no more than the last 7 years or so, excluding the legacy data. So many studies designed to detect the link between flowering phenology and climate, or to detect century-long temporal trends in phenology of individual species or communities, have relied on herbarium-based data. But the NPN data are surely of sufficiently high quantity now to achieve the second and third objectives listed here. Moreover, the NPN data are already of sufficient quantity to validate models constructed using herbarium data, and I'd like to talk a little bit more about these last 2 objectives. So in a paper that Isaac Park and I just published in Global Change Biology, we had 2 goals. First, we used herbarium data to identify the climatic parameters that best predict flowering onset. And then we compared the performance of phenoclimatic models, multiple regressions, constructed from NPN-derived data versus herbarium-derived data for several particularly well-sampled species. So to address the first question, let's just see here, sorry. To address the first question, we first downloaded all available digital herbarium specimen data from 72 herbaria nationwide. And then we eliminated all specimens that were not collected in flower based on unambiguous specimen label information. And the resulting data set had over 500,000 herbarium sheets collected in flower, about 2,500 taxa, representing 119 angiosperm families. We then conducted multiple regressions on each individual species to test for the effect of flowering time, the effects of climate variables on flowering time, using a method called elastic net regularization, which retained the variables with the strongest effect on flowering time and has the added virtue of allowing the inclusion of collinear variables. These models retained, on average, 9.3 climatic parameters out of 25 tested variables. And this figure shows the frequency distribution of the R-squared values of all of the taxon-specific models derived from the herbarium data. And you can see that there's a large number of models that had pretty low R-squared values, which is in part due to the fact that I mentioned before that herbarium data are imprecise with respect to, say, flowering time, particularly for species with long flowering periods. So this slide shows the mean R-squared values across all 2,500 species for the top 10 variables selected by the elastic net regularization method. We were particularly surprised to find that several variables that are rarely included in phenoclimatic models played a particularly important role in determining the flowering times of these species. In particular, the number of frost-free days in each of our tested seasons, as well as the day of year of the beginning of the frost-free period, the end of the frost-free period, and precipitation as snow, had consistently strong effects on flowering time across all taxa. Now, a very important attribute of the NPN data is that we can identify with very high precision the onset and termination dates of intensively monitored plants, which is very likely to yield models that perform much better than the models derived from herbarium-derived data. And in this paper, we set out to test this. So we found 7 species that were particularly well sampled in both the NPN data set and the herbarium-derived data. These are listed here. The NPN data are shown in red, the herbarium data in blue. We had about close to 2,000 records for each of those. And when we looked at the mean R-squared values for the phenoclimatic models that were independently constructed for from the herbarium-derived data versus the NPN-derived observations for the same 7 species, we see clearly that the performance of the NPN-derived data in creating models that explain variation in flowering date is significantly higher than that from the herbarium-derived data. And then just in my last slide, I want to point out that we could also ask this question about the performance of our models for each of the 7 species separately. So these are the R-squared values from the digital herbarium record, the models derived from the digital herbarium records, and these are those from the in situ NPN data. And we find that for 6 of the 7 species, the R-squared values are significantly higher for the NPN-derived data. We believe that the high performance of Cornus was because it just happened to be that the NPN data didn't cover such a wide climatic span compared to the herbarium data, but I'm sure this will change soon. And with respect to all 7 species, we will be able to assert without a lot of doubt that, as we expected all along, the NPN data represent the gold standard for phenological monitoring. And I think I'll end there.
These are your goodies. Thank you so much. Thank you for using the data and demonstrating how great it is. I'm so glad we could hear from Susan, because she's been such an influential person in our formation and growth all along. Now we'll hear a few words from Toby Ault, assistant professor in the Department of Earth and Atmospheric Sciences at Cornell University. Toby has also played a key role in data product development here in the USA-NPN. Oh, that's not the first slide though, is it? And
It's okay, I've got other jokes.
all right.
It's not my only joke.
Okay.
It'd be sad if the one punchline was real before the talk started. And I'm on. Okay, so I have 10 minutes?
Yeah.
I have 10 years and 10 minutes.
Yeah, go fast.
So 1 year per minute. All right, I've got my timer to keep me on track. Okay, And which computer am I actually controlling? The laptop has nothing to do with what I'm doing. Okay, and I have to stay still.
Well, just talking.
I have to talk into the microphone so I can go like all the way around here. Okay, all right, got it. Thank you. This is the title I'd wished I'd given you for my talk, because we've been very interested recently in making seasonal forecasts of seasonal transitions, the timing of spring onset. And all this traces back to work that got off the ground here 10 years ago with Jake and with Mark and with Julio. And I was putting together this talk today, and I had a template that I was going to use, and this image popped up on my screen. It was in the background already, and it's an image that was taken just a couple weeks ago from a weather balloon that we launched over central New York, and it traveled 110 miles, and we chased it down, and we had to rescue it from a farm where it landed from a tree, and the farmer and the landowner came out in his ATV and helped our team get to it, and it wouldn't have been possible without his help, right? And I thought to myself, when I saw this picture and it came up and I'm on my way here, that's another area. This whole effort, this is a low-cost weather balloon. And this experience of having someone help us do science is so resonant, especially now and increasingly so, where the problems that we're up against are so complicated and so big that it requires big teams and it requires participation from entire communities. And so I just wanted to share that with you. And I wanted to also get back to this because there's another question buried in there of, well, why are we launching low-cost weather balloons and trying to put them in the stratosphere in the first place? And I'll try to loop back to that. But we have to go back to graduate school. So this was a picture taken by Scott St. George. Apparently, I don't know why I had that hat in graduate school, but it was what I was wearing to do my work at the time. And I think it was an email that went something like this that kicked it all off the ground. I was talking with Julio over coffee, and the next day, a couple days later, he fired this off to me. No metadata, right? Just a bunch of numbers. This is like some weird test of a graduate student, I guess. Can you make sense of just numbers? Thanks, Julio. You too. Quick question. Would you be able to tell me what the data are and how they're structured? Out of office. This is a little bit fictitious. There's something like this in my memory. The next 6 months. Okay. I'll see what I can do, Julio. No, that's not true. He introduced me to the idea, the core concepts and the history that had underpinned the few years before 2007, 2008, when I was starting to work on these questions, and especially this paper. It's just one of those papers that I come back to again and again and read. Mark Schwartz, obviously, leading role in this entire effort, in this entire paradigm. He also introduced me to NPN and their charismatic leader who had a logo. So watch out with a charismatic leader and a logo. Can ensnare ambitious graduate students into a whole large distraction from their actual dissertation, which had something to do with boring, sad megadrought, and send them off into a completely different direction of exciting research. And one of the things that really struck me about the data that Julio had sent, once I started to piece together what it was, is this idea that you have time series, which I was familiar with the idea that you can do big, large data crunches with time series, but whose independent variable is the day of the year. That just seemed like a really intriguing and compelling way to look at the climate system. And not only that, they had this feature of large scale, I'm calling it coherence, not in the ecological sense, but just the idea that these time series from points across Western North America had variations in the day of the year on which an event occurred and structure in space. And to me, that just smelled like an interesting problem that had something to do with the large scale structure of the atmosphere. And I became increasingly interested in trying to characterize the full range of atmospheric circulation processes relative to the start of spring. And so the really short version of this is lights go out, polar night sets in, atmosphere loses energy to space, you set up a temperature gradient that drives mass flow from the warm equatorial regions to the polar regions, but we have a spinning planet that sets up vortices and jets and unstable weather in the winter, and we're in the winter regime, and it switches back in the opposite direction when the lights come back on. I have animations I'd love to show you, but I will not be able to because I'm using the PDF version of this This is just a visual representation of what that gradient means. Mass likes to flow down gradient just like a bicycle likes to go downhill. And because you've got a gradient setup of energy in the equatorial regions, the tropical region, or the polar regions, you have a pressure gradient and a temperature gradient, and that drives winds. And importantly, it sets up these large scale circulations in both the stratosphere and the troposphere. And there's two different jets that are important for trying to understand the timing of spring and variations in the winter regime. And we put this all together over the course of about a year, started to think about how we could interpret it in a meaningful framework. And I presented this at PACLIME in 2009. I was very enthusiastic, and I had all these graphics, and I'd done even some analysis with models, and I was like, this is such an interesting problem because the structure of the atmosphere in March has a very different impact than it does in April, partly because spring onset has already occurred across Western North America when you're in April, whereas in March, it's sensitive to this different mode, this specific North American pattern in Western North America. And I thought when I gave my talk at PACLIME, it was gonna be like this, right? And it was like this, it was completely, it wasn't even close. And I was really bummed. I was the guy that no one wanted to talk to at PACLIME. The one who had the lunch table by himself. And there's always like one talk where you just like, I don't even know how to talk to the person because I don't want to compliment them. I don't want to like go over there and lie and tell them they did a good job. Because it was like watching a child play a violin for 15 minutes. But Kelly Redmond, the late and great Kelly Redmond sat down and he gave me these words of wisdom. He said, you can become the world's expert on one narrow thing during your PhD. If you want to be a generalist, you just have to get old. And that's pretty much what I've been doing ever since. I've followed that advice. I've been getting older. And now, I did my postdoc at NCAR and learned more about models, and I became faculty at Cornell and had less time to do interesting science problems, but more time to manage postdocs like Carlos, who's very talented and has been working on this issue of spring onset predictability. And there he is giving a presentation about how we're going to try to roll on our first visible attempt earlier this spring, 2018, our first public attempt to make a seasonal forecast of this seasonal transition and publicize it and communicate it and just evaluate how we did in near real time. He'd written the paper, so he was pretty far along in the science. The science really did come first. We didn't just put it out there ahead of the horse. Although it was a little bit of an interesting time to do it because I was also getting my tenure dossier ready, and at some point a faculty member more senior than me in our department came by to tell me that what I was doing was ridiculous. It's probably not going to work, and it was so public that if it went wrong, what would that mean for my tenure? And I was like, I didn't think this one through. Obviously, I did put the cart in front of the horse, but I didn't back down. I was like, no, we're going to do it. I trust Carlos. I trust my postdoc. Then this happened. I don't know if you guys remember this spring, very early in, right after we'd started this effort, and we predicted for the Northeast a late spring, somewhat late spring. It was 80 degrees in Syracuse right away. So I went screaming down the hallway, Carlos, what's the forecast? What's the forecast? He stuck to his gun. He's like, no, I trust the method. And he wrote the method. And we had the world famous Dan Wilkes in the paper. He's like, no, I trust the method. It's going to go back. It's going to switch over. It's going to be fine. Okay, this is the forecast he issued, and he stood by on February 28th, still late in the Northeast. All right, so then we fast forward a couple months to April, and I'm watching my own lilacs very carefully because our forecast was for April 20th. And here it is. We're building up to April 20th prediction. And as you can see, if you go through the days, of course. So this is the 19th of April. And I'm going, come on, lilacs. April 20th, do your job. No, it's late. Okay, well, it's late, but it's like even more late than our uncertainty, our window. It's getting like really late. Now we're going completely in the opposite direction. We're no longer worried about that 80-degree day that happened early in February. I'm like, where's the foliage? And then boom, April 25th, just in the window. We got it. Just barely. And this is the USA-NPN official map on May 3rd. The late anomalies, cold, Arctic vortex winter or late spring really dominated the circulation and dropped cold air down into our part of the world and really made the whole northern section look late and arrive late. And the but why question in a simple sense, traces back to the structure of these circulation patterns in the stratosphere. But we really don't know that much about what's happening up in the stratosphere. We don't know as much as we'd like to know about the large scale circulation. And that's part of why we're launching low cost weather balloons and chasing them down in central upstate New York to try to solve some of these problems. And why I, in my own research, have structured it to rely on citizen science just in the way that I've learned from some of the best people in the world is an excellent way to get things done. So thank everybody so much. People who are with us, people who are no longer with us. Everyone in this room, NPN, thank you.
Thank you so much. Thanks for waking everybody up. Next, we'll hear from Sue Wilder, who will share with us some of the ways that the USA-NPN is supporting land management agencies. Sue worked for the U.S. Fish and Wildlife Service for 23 years as an ecologist and a botanist, and is now enjoying retirement by volunteering for the Gulf Coast Phenology Trail and local conservation agencies along the Gulf Coast. Sue's presentation is entitled Monitoring Phenology on the National Wildlife Refuge System.
Great, thanks. Use this as a mouse?
Yeah. Yeah. Actually, I think it's easiest if you use the that to do.
Okay. Well, thanks everybody for welcoming. I feel very welcome here. I am amongst a lot of phenologists that are actually on the other end of the scope for phenology, the phenology trail, including the folks that are actually on the ground collecting the data on a weekly basis. So I feel very much around very fellow phenologists, and I really appreciate the welcoming that you all have had for us here during this celebration. As Teresa described, I'm a Fish and Wildlife employee, and I've worked on the inventory and monitoring program for the last 4 years of my career as a Fish and Wildlife ecologist. And I was able to help build a phenology network in the southeast, where I'm from, in the Gulf Coast of Mississippi. And I'll talk to you a little bit about that today. I'd like to do two things today. I'd like to talk to you a little bit about Fish and Wildlife and what we're doing in phenology as a monitoring program. And then I'd like to take you on a brief, very brief tour of the Gulf Coast and maybe give you a little hands-on of what we're doing in phenology down there. The inventory and monitoring program in the Fish and Wildlife Service is really just that. It's a program that's tasked with monitoring wildlife and plants and how we're meeting our management mission in the Fish and Wildlife Service. Phenology has been a very important, played a very important role in that. Oops. Can I do that? Page down. Uh-oh.
It's okay. There you go.
There you go. Okay. Oh, and actually, phenology is a very important role. We recognize that in the Fish and Wildlife Service because in our development of our inventory and monitoring program for the service, we actually included phenology and our partnership with the USA-NPN as part of our tasks and our objectives to meet in a long-term plan for inventory monitoring in the Fish and Wildlife Service. And so it's written in our documents. It's actually one of the things that we strive to meet as a goal for the Fish and Wildlife Service monitoring program. We inform management decisions. One of the key things for the Fish and Wildlife Service is to actually provide information to our refuge managers on how phenology is changing over time in our plants and animals on the refuges. And so not only are we making management decisions based on sound science, thanks to the USA-NPN, but we're also helping to educate the local folks in our refuges and around our refuges on how phenology is changing in their communities. We are using the Nature's Notebook, the standardized science monitoring protocols that have been established, and we're very grateful for those because, as many of you may know, refuges don't really have a long history of rigorous methods for collecting phenology data. Most folks in our refuges over the years have put all their phenology data in these things, right? These yellow data notebooks, never to see the light of day again, right? And that's kind of how we've sort of collected data on on phenology and migratory birds, you know, blooming times, fruiting of trees and things like that. It's all in these great yellow notebooks, but again, we are just sort of changing our ways and really relying on some of these standardized methods to help us create more rigorous protocols for our data collections. And then, of course, the phenology data itself is very important to us. It not only helps us to inform our managers of how things are changing over time in terms of plants and animals on their refuges, but it also provides us a way of educating the local communities on how those changes are occurring. And it's also another way of us trying to bridge the gap of when we have a lot of turnover. In the federal government, we have a lot of turnover of folks, and you know, just like myself retiring, it just makes it very difficult to maintain a long-term data set in the federal refuge system. And so having a standardized monitoring protocol like the folks of the USA-NPN really helps us to bridge that gap as people change over and we get new or changes in personnel and volunteers. So we really value the importance of having a standardized method there to kind of help us. Let's see. So again, as we are not only informing science on our refuges through this program, which has been very, very helpful for us, we're learning a lot about the changes that are occurring. Our refuge biologists are seeing a lot of the changes, but they're not necessarily able to document it. And through this work with the USA-NPN and our partnership with USA-NPN, we're really able to start really documenting the changes that we're seeing. In the back, there is a fact sheet about some of the documents or the information that we're collecting in the Fish and Wildlife Service, and I suggest looking through that fact sheet because it has a lot of very good information about fish and wildlife and the partnership with USA-NPN. We have over 20 refuges that are actually engaged in the USA-NPN and Nature's Notebook. And again, the data that we're collecting is local data that actually contributes to a much larger effort. And it's really neat to see the research end of it that we've seen up to this point, because all the speakers before us were talking about the research part of it. And I can see how our data at the refuge level, the local level, really contributes to a much broader understanding. That's what it's all about. It's really neat to be a part of that. And I think the refuge system and the Park Service and the other entities that do conduct data on the USA-NPN really do value contributing to a much larger effort. Okay, so hopefully I have about 5 minutes left and I can take you to a tour of Grand Bay and our Gulf Coast Phenology Trail. So 2 years ago, two leaders, Erin Postumus and Lorianne Barnett, came down to our neck of the woods, and this is a map of Louisiana, Mississippi, and Alabama. And taught us one of their Nature Notebooks classes. And 3 of us were so inspired by that class that we actually said, you know, we really have to do this on the Gulf Coast. We really need to find a way to learn more about phenology and try to build a general local trail where we can help educate folks on phenology data as well as learn ourselves about the phenology. So we built this thing called the Gulf Coast Phenology Trail. And 2 years ago, it started with the red dot near the Alabama border, and that was Grand Bay National Wildlife Refuge. It was started with 3 individuals with 6 plants and has grown now we have over 10 partners, and it ranges from Alabama all the way south to Barataria Preserve, which is south of New Orleans. It's 100 miles long in east and west, and it's 50 miles north and south. So we're really proud in 2 years, a year and a half, that we've really built a fantastic program. And it's basically a collection of different entities like Fish and Wildlife Service. It now involves 4 refuges. It involves 1 national park, an arboretum. You know, all the different conservation partners have really stepped up and figured out that this is really something very important for all of us to on the Gulf Coast to participate in. And so every time we go out, we kind of build a new relationship locally when we start talking about how the Phenology Trail works on the Gulf Coast. And then just to give you sort of a little snippet of what kinds of things we're working on as you work through this slide from left to right. We're going to move east to west, and the boardwalk there is Grand Bay. It is the habitats are pretty much pine flatwoods and pine savannas that are maintained on that refuge to preserve things like you see in the lower picture of the carnivorous plants, the pitcher plants, and then above that the pink orchids and the sundews. So that's kind of one of the objectives of that refuge. And then farther west, we're going to move to the Mississippi Sandhill Crane Refuge, and that is about habitat for the Mississippi Sandhill crane. As you move farther to the west, in the middle of the photograph at the bottom is a refuge called Big Branch Marsh National Wildlife Refuge, and it's preserving the red cockaded woodpecker, which is that woodpecker you see there in the middle. Farther to the west, as we get down into New Orleans and into Louisiana, we have some partners that include the Barataria Preserve and Bayou Sauvage National Wildlife Refuge. Those refuges are swamps, bottomland hardwoods, kind of think of where those alligators live. That's where we are. That's what those habitats are all about. And basically there we're learning a lot about various pollinators. So we're learning about, in the middle there you see a shrub that has whitish flowers. That's eastern Baccharis, Baccharis hemilifolia. And that plant provides the nectar resources and food resources for monarchs and Gulf fritillarias, which are the two butterflies above that. Think about it. We're at the Gulf Coast. We're providing this Baccharis flowers here right now, this time of year, when the Gulf fritillarias and monarchs are coming through on their southward journey. So the timing of that food source availability is extremely important to these butterflies. And we realize now that that may be a real gem. We may be sitting on a real gem and really learn a lot more about the food source availability of for those butterflies. And then finally in the middle in the green plant with the nut green fruits, that's Chinese tallow, and we're learning a lot about invasive species and how the Chinese tallow timing of flowering is very important to our managers, because what we're learning is that as the Chinese tallow is flowering, it actually is the time where all the resources in the tree are pushed into that flowering time, and that's the best time to control it with herbicide or fire. And so we're really providing some information to the resource managers on how phenology can play a role in controlling invasives. Okay, so one thing that we do, we're getting close, right? One thing we do is we take every opportunity we can to build that connecting of building the citizen scientists. I think everybody here has been talking quite a lot about building citizen science networks. Well, we do the same thing on the Gulf Coast. We've contributed to workshops. We've taught teachers how to teach about phenology. We've provided workshops for master naturalists. And we even have opportunities for kids. We have middle school. We have a trail that middle school kids come and on their independent study hour, they come out and they do the phenology measurements. So we really try to get every possible education opportunity we can when we're building this trail. You'll always see us at events and festivals and all that. And so the word is out that the Gulf Coast Trail is a part of our celebrations. So we're real proud. We have 33 observers. We have over 10 sites, and this year alone we've made over 44,000 observations. So we feel like we're contributing to the larger data set, and we're really proud of that. We couldn't do it alone though. We have a coordinator. The USA-NPN helps sponsor that coordinator. She works part-time and she's our organizer. She organizes volunteers. She organizes all these different education opportunities. I call myself the science advisor on the Phenology Trail now, so I am a volunteer, but our coordinator, Gail, is a terrific asset to us, and we couldn't do it without her. So I just wanted to give you a brief tour of the Gulf Coast Phenology Trail, and you know, if anybody's out there collecting data, you know this is a recent fruit drop of red maples, and then we have some beautiful irises at our Bayou Sauvage refuge. So with that, I think I'll finish. Thank you. Hope I put you back on time.
Don't walk away. I'll get you goodie. Thank you so much for showing us how NPN fits in with management. And now, shifting to the Communicate and Connect side of things, we'll hear a few words from Elizabeth Maxwell, who is the Assistant Coordinator for the University of Maine Signs of the Seasons program. Elizabeth will be sharing with us some thoughts on how her work in public outreach is enhanced by the USA-NPN and Nature's Notebook. Elizabeth's presentation is entitled Signs of the Seasons, the New England Phenology Program. Thank you.
Good afternoon, everyone. I'm really excited to be here this afternoon. I was originally scheduled to depart Maine yesterday morning and get in here at a reasonable time last night, and I ended up getting severely delayed and didn't arrive until around noon or 1 o'clock this afternoon. So I'm just excited to actually have made it and be able to meet you all. And sad that I haven't been able to socialize with everyone yet this morning, but there's still time. So. Okay, so I'm going to get right into this. Just kind of a really quick, since I am on quite a bit of a time crunch here, I'm going to give you a really quick idea of who we are as Signs of the Seasons, who are some of the people that we partner with throughout New England, what our volunteer base looks like, just in really general sense, and then speak about a few of the efforts that we do as far as outreach and education is concerned. So Signs of the Seasons got started in 2011, and it is a collaboration between Maine Sea Grant and Maine Cooperative Extension. So Beth Bisson and Esperanza Stanshoff are the project co-coordinators, and the home base is Maine, but it's really intended to be serving all of New England, and we have volunteers and partners throughout New Hampshire and Massachusetts as well. So many partners, which is wonderful. The work that we do could not be accomplished without us being able to work underneath the National Phenology Network and utilize Nature's Notebook. We rely very heavily on the resources that are developed through NPN, and then we tailor them to our specific regions. So we have 23 focus species that we ask our volunteers to consider some of the species on that when they decide which species they're going to include within their own observations. And to give you a sense, so Beth and Esperanza, who were on the previous slide, they are the co-coordinators. I'm the assistant coordinator. My position is traditionally a part-time and only temporary seasonal position. So the capacity that we have as an organization is fairly limited. So relying on these other organizations to help us make some of the decisions about what species are important to include for our purposes. And then reaching out and collaborating with them on different projects and events as much as we can is all what helps to make us a success. So in 2017, at that point, we had trained over 550 observers since the beginning in 2011. This year alone, we trained over 75 new observers. But it's a little bit deceptive because we do work with a variety of educators who will come to our trainings and get trained, but then actually turn around and take it and use it with their classes. So there are a couple of sites where we have one person reporting or one observer, but there's actually many minds behind that are contributing to it. We also have long-term monitoring sites at places like the Coastal Maine Botanical Gardens, and we have partnership with Maine Audubon for several long-term monitoring sites as well. So those are other places where it looks like one point, but it's actually many people being involved. So it's actually a little bit challenging for me when I'm doing the reporting side of things because I can't. It's really hard to get an accurate number of how many people were actually engaging in this process. And this map that you see is just a smattering of the sites that we have. So you can see that we're ranging all throughout Maine with a bit of a concentration in along the coastal areas. And New Hampshire has gotten cut off, and Massachusetts isn't even on here. So there are many other sites as well. But because we started in Maine, that is where a lot of our focus is. I'm not sure if anybody here or how many people here have been to Maine before, but it's actually a pretty big state. So it takes me about a little bit over 2 hours to drive from Bangor to Portland, and another 2 hours to get to Boston. So it's a lot of area to cover, and this is one of the big challenges is figuring out how to actually be able to connect with and work with a lot of our volunteers, because they're in all these different places. So we train up the volunteers, and they get to go to their own backyards or to nearby public areas to be able to make observations and establish sites. So they're not necessarily coming to one specific place and all doing it within a set site. They can establish their own sites. And it's wonderful because we get all this variety. But it's really challenging for me because I want to do things like, hey, let's all get together and have a potluck. But we can't because so-and-so would be driving 3 hours from Presque Isle, and somebody else would be driving 2 hours from Portland, and it's a real challenge. So if you have similar experiences in your programs, please come find me in the poster session, because I would love to pick your brains about strategies that you use to address these kind of problems. But in the few minutes that I have left, I'm going to focus just a little bit about a few of the strategies that we use for education and outreach. So we certainly consider signs of the seasons to kind of have two focuses. One is contributing to the data and identifying areas where we can support researchers in New England to fill out their data profile, but also educating people and using this as a tool to educate people about climate change. One of my favorite things that we've been doing for a couple of years now is having summer webinar series where we collaborate with local researchers. And this is, I think, is really wonderful because it's super accessible. You don't have to ask people to travel. They don't have to take special time away. We have these broadcasted online, and then we record them so people can view them afterwards as well. And it's a really wonderful way for the researchers to kind of distill how the volunteers are actually contributing to their own research program, and then kind of share a little bit of the bigger picture. And then it's also there as a resource in the future for people to be able to go and look at. I mentioned that we work a lot with educators, so we have spent some time developing specific resources for educators to be able to use in the classroom. These are freely available on our website for anyone to be able to use. Some of them are actually quite fun to use with adults when you're doing a training session. So these things are all up there. I have a few, I didn't realize there was going to be quite this many people. I have about 15 small pamphlets that has our website and contact information. So I'm happy to hand those out if anybody's interested later. We've also been working on a newsletter. So this is part of one of my projects this year, was trying to figure out what kind of information people are really interested in getting in an email newsletter, and trying to really pull out not only what's happening in New England, but also going to the NPN website and kind of stealing some of their ideas on what they're advertising as events and interesting news, and sharing that through our newsletter as well. We also have been trying out this species highlight kind of thing. So on our Facebook page, we've been posting species highlights of the species that we primarily focus on, just to kind of help remind people that there are some other species out there and maybe they should think about adding some of them in. Mountain ash is an example of one where I think what's happened in this case is that it's simply not present in some of the sites. And so people just haven't thought of specifically targeting mountain ash, because this is one species where we have really low observation numbers. So this is one of the ways that I was trying to make it a little bit more obvious to people, and trying to encourage them to think about other species that maybe they hadn't thought about in the past. Also highlighting volunteers. And so we've had several volunteers who have been with us from the very beginning and have contributed amazing to our program. And so taking a few minutes to turn back and highlight them and thank them, and also hopefully inspire newer volunteers and see that yes, these people have been volunteering here for 7 or 8 years now, and encouraging them that this can be a long-term activity that they do and make as a part of their life. Also, a variety of publications that we put out. Beth and Esperanza contributed to an article in the Maine Policy Review that's kind of a summary of Signs of the Seasons, and it was a special citizen science issue that they put out earlier this spring. And then we've also been trying to identify some of those researchers who are researching the species, and go and talk to them and have an interview and kind of distill their research down in a way that it makes the volunteers realize, oh, okay, when I go out and I make observation about maples, this is why I'm doing that. This is how that's contributing to the research program. So making those linkages really obvious for the volunteers. And then I was going to talk a little bit about Maine Audubon and how we've been partnering with them, but I think that I'm right at time, so I'm going to respect that and skip through those just to say thank you for this opportunity to come, and I'll look forward to hopefully visiting and meeting most of you a little bit later this afternoon. Thank you.
Thank you, Thank you so much for sharing just a tiny window into how folks on the ground are leveraging USA-NPN stuff to do really great outreach and education. It's so cool to hear. Now we have the distinct pleasure to hear the perspective of Teresa Romero, environmental specialist for the Santa Ynez Band of Chumash Indians. Teresa's presentation is entitled Bridging Culture, the Need for Collaboration with Indigenous People. Welcome, Teresa.
Thank you. Thank you. Thank you, Teresa, for having me here. I have to give an acknowledgement to my friend Alyssa, who actually asked me to be here today and to talk to you all about an Indigenous perspective on phenology and some of the challenges that we have. I am with the Santa Ynez Band of Chumash Indians, but I am also the vice chair for the Coastal Band of Chumash, which is a coastal Chumash group based in the Santa Barbara area. My day started today in a very interesting way. A cousin sent me a message with a text, and it was a link that stated how a tree carving changed the way we understand Chumash rock paintings. And I knew about this article, but it was interesting that he had sent it to me. And I said to him, there must be many, many trees with carvings in them, similar to our cave paintings, which are very famous, out there in the Los Padres National Forest. And he went on to say, yes, there are hundreds and hundreds more trees that I know of in the Los Padres National Forest. I do monitoring for the rock art sites out in the forest with a couple of archaeologists in the area. It's such an advanced understanding of science. This particular tree carving expressed how we traditionally and our ancestors studied the sun and the stars, and it was on a tree in the Santa Lucia Mountains in the Los Padres National Forest. So that's how my day started today, and I thought it was a good lead-in for my presentation. So I'm very happy to be here, and I too want to acknowledge the Indigenous people from this area. We always acknowledge those people, and I believe that's the Tohono O'odham. I have Tohono O'odham friends back home, so I'm happy to be here. So I want to talk about land access, and I know we're really tight on time, so I'm going to try to breeze through these things in phenology. In California, it's a very complex history, but we have very, very small land bases for our reservations and our traditional lands that we have access to. We actually span across 5 counties in California, and I don't know how many people have been to California or this area, but they encompass San Luis Obispo, Santa Barbara, Ventura, Los Angeles, and Kern counties. There aren't enough of us to be in all of these counties. So the folks studying phenology, even on a citizen science level, can really assist us by reaching out to us and working with us, because we have a knowledge base that's different from Western thought and Western science that can really add to the knowledge that's being studied out there. I believe I can do that. This is a map of our traditional area in a traditional sense with all of our villages across the 5 counties, including the Channel Islands, because we were also there. The villages that I'm from are Tipu, which is in the far north in San Luis Obispo County, and the village of Cuyamu, which is on the coast just north of Santa Barbara. This is a comparison map of the same area. So you can see that it's a very, very broad and extensive area. We had inland Chumash, coastal Chumash, northern Chumash, and in each of those areas, indigenous knowledge was there, and many of our communities still hold that knowledge and would love to share what we know with Western science. And so there's a really good handshake that could be made there. So one of the issues we're running against currently, many of our resources in our plants are in areas we can no longer access. So we can't study them because they're privately held lands. Some of them are on ranches. Some are on public lands like the Los Padres National Forest and some state parks, and we can access those. One of the things I'd like to say is some of our plants are so far in the back country now, they're no longer in the lower part and accessible part of the forest, that we can't access them to study them or gather them. One of those plants is chia. There's a variety of chia we use for food. It's only found in the backcountry and not in the lower part of the Los Padres National Forest. So we really do have limited staff resources. My department is literally 3 people right now. And capacities to participate in phenology studies throughout our traditional territories. And I think this is true throughout the globe these days, is we really need the help of academia and researchers out there so that you can work with us and we can work with you to learn what you know and we can share what we know about the plants. Working through Rising Voices, which is held every year, we collaborate with Western science. We call it convergence of Western science and indigenous peoples on a global level. It's through NCAR and UCAR in Colorado, and it's been held in various places throughout the United States. And we focus on climate change and how it's impacting everything. And currently I'm working on a vulnerability assessment throughout our traditional territory. And I'm engaging 9 different Chumash bands in the process to see what is affecting them throughout our region. And as I've mentioned already, many indigenous people across the world have issues accessing their traditional lands. So we should, collaborate, trust one another, and share the information. So we are doing some work locally, which is really good work. We have a traditional plant collective called the Siuktun Plant Collective. It's a traditional collective, and we tend and monitor plants in a preserve in the Santa Barbara area, and it's part of our traditional territory. We're cooperating also with the Los Padres National Forest to tend plants in the forest, and also with a restoration group in their work out in the Los Padres National Forest. And we do need more collaborative approaches. Working with UCSB would be wonderful in research projects that they are doing, to participate in research and restoration in our traditional territory. Some of the impacts we know are happening out there are overgrowth. We have a huge encroachment of invasive species throughout the area. We're seeing migration of plants due to climate change, the drying of plants with no new growth, so they are completely gone. And changes in season of blooming and fruiting times. Elderberry is just crazy in our area. It'll be flowering in one place, and that you probably are aware of this too. and not flowering in other places. So it's not consistent at all. And then it'll bloom many different times. So that's one plant that we know is really being affected by different changes going on. And then increased erosion along the creeks and the ocean due to what's going on. Thank you. I'm almost done. See? I did have some photos on here and I don't know why they didn't come, but that's okay. Thank you so much. Thank you.
Thank you. Our next speaker is Jeffrey Morissette, Chief Scientist with the National Invasive Species Council Secretariat, located within the Office of the Secretary and at the U.S. Department of Interior. Jeff will be sharing some thoughts on where the USA-NPN is poised to go in the next 10 years.
Great. Okay, thank you. I should mention I'm here on behalf, I'm not on behalf of the National Invasive Species Council, possibly just speaking with my previous role on the advisory committee. So I'm not speaking on behalf of the National Invasive Species Council, but was excited to see how many times invasive species has been mentioned in the talks. So I'm supposed to be talking about directions in the next 10 years, and I couldn't help but notice there's an envelope in the back that says, where do you see NPN going in the next 10 years, which I think is the coordinating office way to say, like, thanks, Jeff, but we're going to trust the people here. This is good. You can fill some time with us. So, and so that's probably very appropriate because it was a daunting challenge, and I've lost sleep literally going, what if I talk about things that have already been done? I haven't seen anybody others talk, and you'll see there is maybe some overlap between where NPN is heading, or where I think it's heading, and where it's already been. And I thought since it's a 10-year anniversary, I'd be like more narrative and description of kind of where they've been in the next 10 years and where they might go in the next 10. And so it was in 2005, I was doing a detail at NASA headquarters, and Ed Scheffner, I was working with Ed Scheffner, who was with the Applied Sciences program, who was invited to the initial meeting that was here in Tucson. And he was busy on travel, and he had known that I was doing some land surface phenology work with MODIS and predicting habitats for invasive species. So he said, he asked me if I could attend on his behalf. And so, but if Ed would have been free to come, I wouldn't have been involved with NPN. So I feel really lucky and grateful to be a part of the roster. And there's Joe Caprio. I don't know if Mark is going to show pictures of Joe Caprio, who was at that first meeting, who initiated the Lilac Network and did sketches, hand-drawn sketches on maps of where they were blooming. And just was really excited to be a part of that initial meeting. And then I look at these pillars of the ecological phenology community, and I don't know if it's just that I feel like I don't know nearly as much as they do, that I feel like younger, but like my daughters would be like, no, you're getting old too, Dad. You're sort of, so, I'm like, it's, to be like there with these older, these people who have so much experience. And I don't know, I guess I have as much experience, but maybe the knowledge is not, I don't seem to be catching up to the knowledge of these folks. Like I said, this will be a little bit more narrative. So in recognition, again, it's great to hear the Tohoto O'odham original sort of folks on this landscape. Great to see that recognized. I think I'm gonna hit what to go forward. The arrow. There we go. Okay, so, oh, well, let me back up. Nice classic historical pictures. I think it was my birthday or a neighbor's birthday, and he said that the days take forever, but the years fly by. And so I want to recognize that, that seems like it's been, I'm sure it's been a daily challenge, and Jake spoke to that, and there's technical challenges that the NPN has overcome. There's issues with budgets and continuing resolutions as a federal program, and there's the bureaucracy that's day to day, and it seems probably like they go on forever and ever. But when you look at the years and how they've flown by with these 10 years, and there's just this incredible increased awareness of phenology in the ecological community, expanding way beyond just lilacs across all taxa and different life form events, and we saw some of that with what was shown. And that, we've clearly established phenology as the physical living manifestation of the dynamic and changing climate in which we live. It is a credit to what the National Phenology Network has done for the last 10 years. So I wanted to kind of compliment them on that before I went on to this. When I was in graduate school, I had the opportunity to go to the International Space University, where it was space camp for graduate student geeks, and I had the opportunity to meet Jim Dater, who's what he called a futurist at University of Hawaii. And he had said, and it stuck with me, that any reasonable or believable prediction of the future is probably not going to happen. So go forward a little bit. This book that's come out of the economic and Wall Street community about black swans. It's all swans are white, and you go happily believing that all swans are white until you see a black swan. And so black swans are this terminology for an event that completely unexpected, really rocks the system, changes it, the dynamics completely, and then was perfectly predictable in hindsight. So 9/11, Wall Street crashes, Black Fridays and whatnot are black swan events. I think in ecology, we might call them tipping points or state changes. And so we see those. And so I thought I would caveat Jim Dater's quote and my belief in what the black swan philosophy says to say, I have no idea what's going to happen in 10 years. And I'm done. Thank you. No, I'll talk a little bit. I'll go forward, but with that understanding that, please fill out the cards for the envelope and give them a little more guided insight on this topic. I'm one of the few ecologists that I know that spent time working in an automobile factory. I worked at the Ford Escort engine assembly plant when I was working on my master's degree. Does people remember the Escort? I mean, it's kind of like the Prius of the 80s, maybe. I mean, it was everywhere. It was kind of fuel efficient. Pretty good engine, but not nearly as good. And so this was in the early 90s when the auto industry in Detroit, and I'm from the Detroit area, was still reeling from the disparity between quality of the Japanese automakers and what the US was doing. And Edwin Deming matriculated from the census onto be a consultant and learned from the Japanese and really brought statistical process control and quality control to the US and was quite a guru and well recognized. I'm proud to have a signed copy of this book in my office and attended one of the seminars that he did. But what struck me when Jake and I were talking about coming to this 10-year anniversary is this constancy of purpose that I remember Edwin Deming saying was important for success, and at that time in industry, but I think it's equally important for technology and advancements in science. And you can see there what he was laying out as what it meant to have some constancy of purpose. And so I don't have a picture of her, but when I worked at Ford, there was a woman named Ellen Barnes who was in charge of the quality control of the light truck division at Ford Motor Company. And light truck means anything that's not a semi. So, if you and I would buy light trucks, even the biggest ones you buy from a lot. But she was tenacious and committed and really subscribed to the ideas, hired those graduate students to do things. And then, so, fast forward 24 years later, my neighbor was selling a truck and I was like, I might need a truck to bang around the house. It might be good for yard work or renovations. And this guy's telling me how great the truck is. And it turns out it's a Ford Ranger that was built in 1992. So I'm like, we have Ellen Barnes to thank for this quality control and vehicle that's still running all these years later. So, I think that constancy of purpose, and what I would say is my first prognostic, is that because of the dedication we've seen over the last 10 years, that the USA National Phenology Network is going to continue to be important. And I would say and argue that even more so in the next 10 or 25 years. I think the foundation that's been established is amazing, and we're yet to see the results of that. Okay, but I would add that continuing forward is going to require that same constancy of purpose and dedication. I don't think it's a mistake that you've had one executive director and the program's been highly successful. You've got really dedicated employees and consistently supported by USGS. So I would encourage the powers that be, or for people to consider this, that's an important part of the success of the last 10 years and will be an important part of the success going forward. This is an emerald ash borer. I've got 4 ash trees in my yard, so Shane, just to sort of clarify or mention that. But I think the prognostic phenology that we're seeing here is the next thing I would like to say is there's going to be that moving forward. And I think what was interesting about this, my own personal experience with this came out, Alyssa, I think, blasted it others to an email. I forwarded it to some friends in the Animal Plant Health Inspection Service, APHIS. And they forwarded it to somebody else. And then there was a phone call and a couple of things. And it was sort of interesting to have these folks who are doing similar work with the Forest Service have the call and the open access to talk to the coordinating folks here at the coordinating office to think about, in a very open exchange, how to improve that and how to bring that to where they are. So not only is it prognostic phenology, we saw a little bit about this in near-term forecasting. It's really great to do these correlations between gridded products and NPN data, because you can't really predict the citizen science is going to predict what they see next spring, but those gridded products, because of bright folks working in this near-term climate forecast, can predict those. So I think this field is growing, and I'm encouraged with that collaborative spirit to bring that prognostic to where the land management agencies need it to be, and working closely with them. So I thought that was excellent, and I think shows sort of something that will move forward. Okay. The third and final prognostication is moving forward, moving away from calendar dates and moving into this more interrelated, cyclical, seasonal, and interdependent phenology. And I think this comes from indigenous cultures. Shannon McNeely, when I was at the Climate Science Center, did work with the Native Alaskans. This comes from the Library of Congress. There's excellent work that's NSF funded by Dr. Kassam. I think he's working with indigenous people, none in the US, working to understand, what are they seeing in an eco calendar as opposed to the calendar. I mean, that calendar is important because it's really reflecting where the Earth is relative to going around the sun, which has some obvious important climate implications. But we know now there's a lot of subtleties in those climate and the changes in the dynamics of the climate. So that, I think that, first might be important, but, is it the same as, or more important than growing degree days? Or is it when the birds and the flowers are coming? And it might relate to fish spawning or mushroom seasons, as they show here. When Karim Qasim goes to these indigenous communities, he asks them, he has dinner with them, sits them down, forms a community, and then he asks them, how do you know when winter is over and spring begins? And I'm guessing they don't look at the calendar to say when the equinox is. And then he defines eco-calendars. I'm going to read it so I make sure I get it right. An eco-calendar event is known in the community. It's observable throughout the landscape. It's responsive to climate trends, and those three things are similar to what we've seen, and it's synchronized with livelihoods. And I think that makes a real interesting component to what he's working on. So I think that these things show a real exciting interrelationship that, kind of says it's not just calendar, but how living things are connected to each other and interacting with each other. I think that's all I have. Although now for Jake, I got a new logo. I subtly did it in the same font, predicting instead of taking the pulse of the planet. And we'll do it for years to come, hopefully. So it's great to be here, and congratulations to NPN for 10 years. Okay.
Jeff, can we start calling you Punxsutawney Jeff then, with all the prognosticating? Thank you. Now we will shift to a special part of our program where we'll appreciate and reflect on how this endeavor got started. We'd like to acknowledge the significant contributions of the two individuals that founded the USA-NPN, Mark Schwartz, Distinguished Professor of Geography at the University of Wisconsin-Milwaukee, and Julio Betancourt, where'd he go? Okay, there we go. Thank you. USGS Scientist Emeritus. We have something for you both. Could you, and then we'll have a few moments for each of you to share your reflections. So could you both please come up here for a moment? Distinguished Professor Mark Schwartz held the vision for this network for many years. Mark's foundational work has brought the word phenology into the scientific lexicon. Over the years, Mark has made enormous contributions to the network, including garnering initial funding, bringing together key individuals to shape the network and providing thoughts on direction. In addition, Mark generously shared his spring indices with the NPN, enabling this young organization to have a signature data product early on. Julio Betancourt has likewise been crucial to the creation and growth of the USA-NPN. One of Julio's most significant contributions to the network was to convince USGS leadership of the value of this endeavor. Because of Julio's tireless efforts, USGS committed to creating and hosting the USA-NPN Executive Director position and launched what has now been a 10-year investment by the agency. Julio has served as a thought leader within USGS and the broader scientific community for his entire career. His realization of the value of phenology and investment in ensuring that phenology is something that is carefully documented across the country has been crucial in the network that we celebrate today. Mark and Julio, we are all indebted to you. Without your vision, commitment, and persistence, the USA-NPN would not exist. Thank you from all of us in the National Coordinating Office.
Make sure we get this right too, Mark.
Okay, they told me I have 5 minutes, and some of you that were at some of the conferences know that I never speak without a script except under special circumstances, so this is one of them. And I promise not to do any Kennedy-esque things like I did in Milwaukee, but so I'm very extraordinarily privileged to be here. This is just unbelievable at certain levels. I think if 30 years ago, that person, if I would have told them what was going to happen, they would have said, "You got to be kidding. There's no way that could possibly happen." So I've been able to have a number of extraordinary things happen during my career. I want to focus on the network, but of course, just phenological research. Some 30 plus years ago when I started phenological research, no one knew what it was. I still am kind of miffed that in Word they still want to replace it with phrenology when you put it in. And but that changed by the end of the 1990s. Suddenly, phenological research came into its own, and that's an unusual thing for things to change like that. I've jokingly said that the world came around to my point of view, which was extraordinary. But then there was the network, as she stole a little bit of my thunder, but as I was going to say, the vision, I thought about it for a very long time from when I started to get the lilac data, and I realized it had to be more. It had to be more than just the lilacs, although, you know, I've got the tie on, Ellen. It's not actually lilac tie, but that's another story. I'm still searching for a lilac tie. The whole idea of this was that basically we needed to have some way to make this happen, and it wasn't happening. I had some very powerful people try to help me make it happen, like Tom Carl in the early 2000s, and he tried a whole bunch of things that didn't work. And then Steve Running, through a somewhat, I guess in science, there's serendipity, introduced Julio and I to each other, and Julio had the wherewithal to make this happen. So it's not enough to have a vision. You have to have a way to make things happen. And so that was really something that meant a lot to me. The other thing is that I've sometimes teased Teresa and others that working with a network has never been my day job. It's always been something that I've done on the side, working with the observers and all of that. And the other thing that really is needed to make this possible is a professional staff and the people coming together who have made it their career. And so I'm deeply appreciative of that. And I really want to thank you for that. But the one thing that I will leave you with is that I want to remember and keep us thinking about the vision, because I'm going to sort of steal something from George Bush the Elder and say he said 1,000 star points of something. The 1,000 permanent observation stations is still something that drives my thinking around the country and what that might be possible to do. Maybe we'll never achieve that, but we should continue to try to work for that because phenology is not only important, it is crucially important in so many ways for what we need to do going forward. So thank you very much.
Good afternoon, everyone. My 37-year-old son listened when he was out in the field with me, and one day when he was in his 20s, he said, "Dad, you know, all of this is really about navigating opportunity." And he was right. I had told him that a million times. I'm always right. I had the wonderful opportunity to be co-located at the University of Arizona as federal scientist. Many people in the USGS oftentimes said that I probably had the best job in the survey. And, you know, here I was, an interdisciplinary scientist that was located at a quintessentially interdisciplinary Research One university. And so I basically had to navigate opportunity. In 2004, I was promoted to the executive service as an active scientist in the USGS, and that's usually a license to lead. And my philosophy about leadership is that it very seldom is about leaders, it's about followers. And I don't mean that in a derogatory way, I mean that it's really about followers. I was out in the field with one of our graduate students, who was graduate students at the time with Toby, Ali McAlady. And we were doing something completely different than phenology. We were spending a lot of time in cliffs in northeastern Utah. And she had recruited a bunch of people to come in the field and help us. And on the second day, this lady arrives that is a whirlwind. With a few beers, I'll tell you other stories, but we were sitting around the campfire drinking beers, and she pulls in this little vehicle and almost immediately hits the ground running. One of the things that she did is she started telling me about the National Phenology Network. And I thought, this is wonderful. It has nothing to do with me. I got the sensation at the time that this was gonna last. And I had that experience starting in 2004 at a meeting that was set up to look at one of the 6 grand challenges faced in the environmental sciences, but particularly being faced by the National Ecological Observatory Network. And when I was leading that workshop, and there were National Academy members out of the 30 people that were there, it just occurred to me to say something really crazy right at the very beginning. And I said, how many of you can tell me how variations in phenophase in time and space modulate population abundance? And I saw mouths dropped. They'd never really stated, they'd never heard it stated that way. And I said, there are reasons why this is a hard question. And the main one is that we have failed as ecologists to produce spatial temporally dynamic data at the continental scale. We've done it with birds. We haven't done it with any other species. We haven't done it with something as basic as phenology, and we haven't done it with something as basic as demography. And so there is an opportunity here for NEON to go wall to wall. It ended up that at that meeting, I mean, it was almost like a 1960s moment where I had this flashback, and the room divided into two, and it was really divided into two. There were people who wanted to match the spatial and temporal scales at which physical scientists worked. And there were people, ecologists, who wanted to measure the crap out of everything in one place. And that was a tension that exists to this day the reason that I'm saying that is the National Phenology Network is an outgrowth of that tension. It was actually kind of a remarkable thing because everywhere we went where we had this conversation, it resonated, including USGS. After the first big meeting and then an implementation meeting where a few of us went to Reston, locked ourselves up in the conference room with all the leadership, the executive leadership team, and people said it was the fastest hour in that room they'd ever spent. And 5 different divisions, geology, water, biology, geography, and informatics, all put in the same amount of, within a day, all put in the same amount of money to start the National Phenology Network. That was actually kind of incredible. So this has been really an idea whose time, not only an idea whose time had come, but an idea whose time was long in coming. For me, it's beautiful to see what has happened in the last 10 years since we hired Jake and opened the offices in 2007 here at the University of Arizona. I mean, looking back, it's really humbling. And I've got to say that, you know, Mark and I had a hand in sort of pushing things, but it was really implemented, you know, by Jake and Teresa and Alyssa and Kathy and Aaron and Lorianne, these people, Lee and Jeff, these people that man the National Coordinating Office, you know, and keep the trains on time. It's really been a remarkable thing. And I moved to Reston, Virginia, to headquarters in 2013. And part of my leadership activities there was to start this Council of Senior Science Advisors of all the executive level scientists across disciplines in USGS. And we led this Grand Challenges and Integrated USGS Science Workshop that ended up boiling down the Grand Challenges to 4, one of which was anticipatory science and management of changing landscapes. And that's really the vision of the National Phenology Network, is to actually be able to provide, at least in terms of timing, seasonal timing, to provide the kinds of products that are going to be used in the future, in the short term, the near term, and the far term. So congratulations to everyone on just an incredible effort. And I've got to say that one of the most touching things in the celebration was watching both Jake and Mark get teary. Thank you very much.
Yeah, I didn't plan that. That's just great. You know, but tears make it really very poignant. Okay, we're almost done because I know there's snacks and drinks and all sorts of great stuff out there. I just wanted to share a few words about the poster that we just gave to Mark and Julio. This poster was created for the USA-NPN to celebrate our 10-year anniversary by a local artist, Kara Gibson. The ideas were contributed by our staff and was created to emulate the Works Progress Administration style of artwork. The landscape is intended to be generic to represent any place in the country where people may be monitoring. The tree is a cottonwood, which is one of our campaign species, and the observer represents one of our former staff members, Patty. The picture incorporates the 4 seasons and the associated phenological stages, as well as weather as a driving variable. There are posters available in the back or out in the courtyard somewhere here, available for all of you to take. And if you're flying, we have cardboard tubes for you to put them in as well. And before we go, thank you, Julio, for getting us started on this. I'd like to recognize the wonderful individuals that have comprised and do comprise the USA National Coordinating Office. Jake and I have had the pleasure of working with many of these individuals for many of the past 10 years. So I'm sorry, NCO members, but please stand up so I can acknowledge you. We are Lorianne Barnett, Education Coordinator, Ellen Denny, Monitoring Design and Data Coordinator, Kathy Gerst, Data Product Coordinator, Lee Marsh, IT Coordinator, Stuart Marsh, who assists with planning and administrating. You gotta stand up too. You're part of the team. Sharon Oliver, Administrative Associate, who's been fluttering all over the place getting all these logistics dealt with today. Erin Posthumus, Outreach Coordinator and U.S. Fish and Wildlife Liaison. Alyssa Rose Martin, former Assistant Director and Partner and Application Specialist. Sarah Schaefer, thank you for all the assistance just now, Multimedia Design Assistant. Jeff Switzer, Systems Analyst. And Shane Selleck, Communications and Outreach Coordinator. Also, I would like to acknowledge Carrie Inquist, our former staff scientist as well. And of course, Jake, the Assistant or Executive Director. We are also fortunate to have several very talented students as part of our team currently. Sierra Friedenland, Deanna Hatch, Diego Huerta, Brenda Mabu, and Jenny Moscato. Very sadly, there is one member of our team who's missing today, and that is Patty Gerton. We lost Patty in May of this year, and our team has felt different ever since. Patty was caring, humble, generous, and a devoted member of the team. She kept meticulous, detailed records to categorize and describe each species added to the Nature's Notebook system and created the content for several of our foundational educational resources, including the Botany Primer, the Phenophase Primer, and many Nature's Notebook nuggets. She always made time to write a carefully detailed response to an observer question or to help a fellow staff member puzzle out a species identification. Patty saw the beauty in every environment she visited and called home, from the lush forests of the Pacific Northwest to the ever-changing Sonoran Desert. In addition to an exceptional eye for detail, Patty possessed genuine wonderment at the natural world and a deep knowledge of its plants and animals. We remember Patty as she lived in a beautiful, quiet spot of nature with a paintbrush in her hand and love in her heart for the people and the places surrounding her. This concludes our speaking program, and you're now free to go outside and enjoy some refreshments. But hang on, we have one more thing to ask of you. As Jeff alluded to, we are truly interested in hearing from you. So please help us reflect on the past 10 years and shape the network in the next 10 years. We will have, or we do have, 3 stations set up in the courtyard where you can write down your perspectives on what we've done well and what we might do better next time in the next 10 years. Thank you all so much. Oh. Thank you guys so much.